Hey guys, hey, welcome back. Welcome back to the next installment of Learning Math with Mr. Bauman from Mr. Bauman's basement. So, move the camera a little bit, move the chairs a little bit, get a little bit of a different backdrop so you don't have to keep staring at the same wall. Got a few, got the pool balls over here. Some hats that my wife and I wore when we went to Philadelphia to see the Pope. I got, of course, a picture of Jesus right here. My grandparents here. My other sets of grandparents over there. One of our wedding pictures here. So it's a little bit of a picture collection of Mr. Bauman's family. Before we get started with the math, little question here to start off. Who do you think this is a picture of? Give you a few seconds to take a look at this picture. Look at that good-looking guy. Who do you think this is a picture of? Kind of looks like Mr. Bauman, right? Well, guess what? If you guess Mr. Bauman, you are not correct. This is actually my grandpa. Everyone always said that we looked alike. Gosh, that certainly does look like me, but it's not. It's my grandpa. He was a Greyhound bus driver, but apparently in his free time he also liked to box. So anyways, I really love this picture. This is probably 80 years old. But apparently they boxed back in the day. So anyways, we're going to jump right into the math. What's our goal for today? Today, we're going to hit the last few standards from 8th grade. In fact, these are the last 3 standards. So kind of hit about 3 standards here in one lesson. We're going to try to keep this right at 30 minutes, hopefully. Fingers crossed, right at 30 minutes. But we're packing about 3 days worth of lessons into one lesson. So 3 standards here. This lesson is going to knock your socks off. Uniform socks or otherwise. I'm guessing you probably don't have uniform socks on right now. Who would? Because we're not in school, unfortunately. Certainly wish we were still in school. Let me zoom this back a little bit. I really miss seeing you guys. I miss you a lot. And I certainly hope that you're enjoying your time at home. I know it's not ideal, but we're making the best of it, making the best of this e-learning. I'm making the best of the resources I have here at home, and I really appreciate you guys' efforts so far. I've been really impressed with the work and the time and the energy you've put into your learning, even if from home. So got my whiteboard here, got my marker, got my magical eraser, and got a few other things we're going to be using for this lesson. And of course, got my hot coffee. Actually, today it is kind of hot, and it's good. We're going to jump right into it. So again, three standards in one lesson. This is the last few standards. We're going to jump into probability. We looked at a little bit of probability last year as 7th graders. Adjust this camera a bit. I'm going to pull this down a bit. We looked at probability a bit as 7th graders, and we're going to revisit some of those similar standards, but jump into some new stuff as well. So what's our objective for today with this probability? I'm reading backwards, so bear with me here. We are going to be able to calculate the probability of compound events. That's objective number 1. That's standard number 1. And if you need to pause the video, I'm going to keep reading. Compound events, and determine the sample space using what we call tree diagrams. But also, I'm going to show you a shorter way to do it called the FCP. The FCP, that stands for the Fundamental Counting Principle. The Fundamental Counting Principle. So 3 standards in one. Be able to calculate the probability of compound events, that's 1. Determine sample space, that's number 2. And tree diagrams and the fundamental counting principle, standard number 3. So the last 3 probability standards for 8th grade here today. So hold on tight, buckle up. We're going to hit these 3 standards coming right at you right now. So I'm going to erase here real fast. If you need to grab your notebook, if you don't have it, grab a pencil. probably not gonna need your calculator, but if you wanted it handy, we should be able to do most of these. And I'm just looking around, I forgot my calculator. So I'm gonna have to try to do these in my head. But you can certainly check my work with your calculator if you need to. Alright, so quick review from 7th grade. In 7th grade, when we talked about the probability of an event happening, it could be written as a fraction, certainly. It could be written as a decimal, but it could also be written as a percent. As long as they're equivalent, it doesn't matter which form of the number you put it in. Secondly, when we use probability, we use capital P to represent the probability of some event occurring, and the notation looked like this. Capital P. So this means the probability of some event. Doesn't matter what it was. The probability of rain, the probability of me having a green shirt on, the probability of me drinking hot coffee, the probability of you folding socks at your house. All these are going to be different numbers. And in last year, we calculated this as a fraction. So we called it favorable outcomes go on the top, divided by the total outcomes is the denominator. So the probability of some event equals favorable outcomes divided by, so this fraction bar means division, divided by the total outcomes. And last year we used words like likely. The probability of it being above 50 degrees today, it was likely. It happened. The probability of me folding socks today is unlikely. And usually that's somewhere around like that 20-25% area. Things that are likely, like it being above 50 degrees today, we usually attach that somewhere around that 70-80%. If something is certain, like the probability of the sun rising today, that was 100%, so we use the word certain. The probability of pianos falling from the sky today, that's zero. That's zero. That's impossible. So there's different words that we use, and we're going to be using some of those words today. So I just wanted a quick review. How do we find the probability from 7th grade? What we're going to be doing today is not what they call simple events, but compound events. So events are compound if they, so two or more events, if they happen at the same time. Just writing this out as fast as I can. And if you need to, again, pause your video. Compound events, two or more events that occur at the same time. For example, I could flip a coin, and at the same time I could try to throw a ping pong ball into a bucket. The probability of me getting heads and making the ping pong ball into the bucket is pretty low. You know, my toss into a bucket's not that great. The probability of me getting heads it's 50-50, but the probability of me getting that ball into the bucket is fairly low. The probability of me flipping a coin and getting heads and getting an even number on a dice is probably going to be a little bit higher. And I'm going to teach you how to do that today using what's called a tree diagram, but also using multiplication, just straight up multiplication. So that's what compound events are. Two things happening at the same time. We're still, whether it's compound events or simple events from 7th grade, we're still going to use the same formula, or the same setup. So it's still going to be, and I'm just abbreviating in here, we're still doing favorable over the total. So make sure you get this in your notes. Whether it's compound or simple events, it's still calculated as favorable divided by the total outcomes. All right, so let's take a look at an example. That's kind of the setup. Let's jump into some specifics. Okay, so you can call this your first example. So we're going to calculate. Let's do the probability of spinning, and let me show you with the camera what I have here. I found a spinner in our house. We have a game of Twister in our house. We're going to disregard all of these colors on the edges here, and we're just going to focus on the 4 main sections of the spinner. We have right hand, left hand, right foot, left foot. Okay, so we're going to say that this spinner has 4 sections. I know it has colors on the sides, and we're going to disregard those for a second. We're just looking at the 4 main sections. Right hand, right foot, left foot. 4 sections. In addition to that, I have a dice or a die. This is just a regular old die, numbers 1 through 6. Okay? So there's 2 things happening here, so that's what we're calling a compound event. So we're going to try to calculate the probability of spinning, and I'm just going to abbreviate this RH for right hand, and there's where the compound part comes in, and let's try to roll an even number. Again, if you need to pause the video, go ahead and do so as you get down these directions. Calculate the probability of spinning, again, RH is just right hand, and rolling an even. So that's kind of the setup. Now, what would this look like in terms of a tree diagram? So if I want to find what we call the sample space, that's a word from last year. The sample space is like how many things could possibly happen. How big is this space, this total possibilities, how big does it look? So let's try it. And in order to figure out this sample space, we're going to use what we call a tree diagram. And I know we've done tree diagrams in the past. Let's try it again. They call it a tree because it starts small and just kind of branches out and kind of expands. Sometimes the trees are fairly small and sometimes they're really big. We're going to decide how big is this tree, how big is the sample space. So the size of the tree is really the size of the sample space. So let me try. So we're going to call this tree diagram. Let's start with the spinner. Okay, just because. There's no particular reason. It doesn't matter which one you really start with. So we said this spinner has 4 main parts, right? So to start off this tree, we're going to start with 4 branches. Right hand, left hand, right foot, left foot. So our tree kind of starts off looking something like that. Again, if you need to pause the video, go ahead and do so to get caught up. At the same time I spin the spinner, what am I going to do? I'm going to roll the dice. What are we looking for? What would be favorable on the dice? We want to use some words from 7th grade. A favorable event on the dice, keep in mind the directions that you just wrote down. We're trying to roll an even. So favorable is even, unfavorable is odd. Favorable is even, unfavorable is odd. So there's 2 possibilities when I roll this dice. I know there's 6 sides to the dice. I know that. But you keep in mind what's favorable, what's unfavorable. Favorable is even, unfavorable is odd. So when I roll the dice, there's really only 2 possibilities. It's either even or it's odd. So from each of these branches, I'm going to have smaller branches, and from each of them, I'm going to have 2 small branches. And I'm going to call it E and O. I'm just abbreviating here, even and odd. So this is what our tree would look like. So I could go right hand even. That would be great. That's what we're looking for. But it could go right hand odd. It could go left hand even, left hand odd, so on and so forth. So how big is our sample space? That's right. We have 8 different possibilities. There's 8 total outcomes that could happen. So our sample space And I could write all these out. I'm not going to bore you with that. I think I'm already boring you enough. The sample space has 8 total outcomes. That's it. There's only 8 things that could happen. When I spin the spinner, I'm going to do that here in just a second. When I spin the spinner and I roll the dice at the same time, these compound events that are happening, there's only 8 possible. We're looking for this one. We're looking for right hand and even number. Let me get some space here on my board. So our probability of right hand and even, the probability of right hand and an even number, sorry that's kind of sloppy. Again, it's favorable divided by total. We just got done saying the total is 8. So the denominator is definitely 8. How many of those 8 are favorable? That's right. There's only one of them. There's only one way for this to work. There's 8 total. Only one of them is favorable. So the probability of me spinning right hand and rolling an even should, in theory, only happen one time out of 8. This is where your calculator would come in handy. If you wanted to write this as a decimal, go right ahead. So let me think for a second. This would be half of a fourth. A fourth is 25%, so half of that is 12.5%. And as a decimal, that's 0.125. Check my work. I don't have a calculator down here. Check my work, but I'm pretty sure that 1 divided by 8, if you want to write this as a decimal, would be 0.125. And if you want to write it as a percent, because that's just the way you roll. That's the way you roll. It's the way you roll. That was dumb. 12.5%. That's correct. So you can write it any of these 3 ways, and I would give you full credit. Alright, so that's with a tree diagram. At this point in class, I had asked for questions. Unfortunately, we're not in class. If you do have questions at any point while you're working on this assignment, please send me an email. Some of you have been sending me emails throughout the day. Perfect. That's what I'm here for. I'm here to answer your questions. I'm here to teach you the math, but I'm here to answer your questions as well. So please use me as a resource. All right. At this point, take a drink of coffee. So you might be wondering, okay, that's great. I got it. Tree diagram. That's fine. No big deal. But what if the sample space is really, really big? Would you want to make a tree diagram that had like 24 possibilities? Would you want to make a tree diagram with 36 possibilities? 100 possibilities? 1,000 possibilities? The answer is no, right? There's got to be a faster way to do this. Let me show you how to do that. So same problem, but this time let's label this in your notes as a shortcut. So the shortcut would be for each of the events, for each of the compound events, find the probability and then multiply those together. So find the probability of each of the events. In our case there was 2 events, right? Spin the spinner, roll the dice. There's 2 events. Find the probability of each of those and then multiply them together. So let me write out what I just said. Multiply together the probability of each event. Again, if you need to pause the video, the shortcut, instead of the tree diagram, this is what you could do. Multiply together the probability of each event. The product is the answer. The product is the compound probability. Again, pause the video if you need to. I'm going to move on. Let's do the same exact problem. Probability of spinning right hand and rolling even. Same problem. Haven't changed that. Probability of spinning right hand and rolling even. So the shortcut, find the probability of this, find the probability of this, and then multiply them together. Let's try it. What's the probability of spinning right hand? The probability of spinning right hand on the spinner, it's 1/4, right? It's 25%. Let's keep it as a fraction. I think it's going to be a little bit easier to multiply. So spinning right hand, that's 1/4. This one's a little bit trickier. What's the probability of rolling even? It's not 1/6. Remember, there's only two possibilities when you're considering even versus odd. It's either even or it's odd. There's only two choices. Only one of them is favorable. So the probability of rolling even is 1/2. And I just got done saying, once you have these two probabilities, multiply them together. And oh my stars, we get the same thing. We still get 1/8. And we avoided making a tree diagram. It's good food for thought. This is a big one right here, especially when you work on tonight's assignment or today's assignment. This shortcut, it's going to be really helpful. You can certainly make a tree diagram, but if you know the shortcut, and some of these sample spaces are going to be really pretty large, I would really take this ball and run with it. All right. Let's try another one, just because this is exciting. This is you know, this is what the Hokey Pokey talks about. This is what it's all about, right? This probability and statistics. You're going to be doing this again in high school. You're going to be doing it again in college, and the Hokey Pokey doesn't lie. Neither does the math. All right, let's try. Same spinner, same dice. But let's do the probability of right hand and rolling a 5 this time. Now, before you pick up your pencil, before you pick up your calculator, I want you to think about this for a second. In class, this is where I would kind of seek your opinion or seek your explanation. Should this be higher than 1/8 or lower than 1/8? The probability of right hand and rolling a 5. Do your chances go up of this happening compared to the last problem, or do the chances of this happening go down compared to the last problem? I hope you have an opinion, and let's try to justify it. Let's try to show whether yours is correct. So right hand, and by the way, let's not use a tree diagram for this, because you're going to find out here in just a second it's going to be way too big. Probability of right hand, we already know that. That's 1/4. What's the probability of rolling a 5? It's 1 out of 6, right? There's only 6 possibilities on this dice, 5 being one of them, right? So you got a 1/6 chance of that happening. Multiply them together, so the probability now is 1/24. How does that compare to 1/12? It's a whole heck of a lot smaller. So if you guessed your probability here should be smaller than the previous problem, good job. You got it. All right. Let's take a drink of coffee. And I'm just realizing I forgot to actually do that experiment on the previous problem, the one that we got 1/8. So sorry to backtrack, kind of jump the gun a little bit, do a little experiment here. So we said the probability of right hand and even should have been 1 out of 8, right? Sorry to backtrack, this is the previous problem. So in theory, this should happen 1 out of 8 times. So if I conduct this experiment, and I'm going to here in just a second, if I conduct this experiment, is it guaranteed to happen 1 out of 8 times? No, there's no guarantee, but in theory, it should happen 1 out of 8 times. This is what we talked about in 7th grade. This is the theoretical probability. The experiment that I'm getting ready to do is called the experimental probability. Sometimes they're the same, sometimes they're different. They're not always going to be the same, which is why you shouldn't gamble, right? Because in theory, the theory doesn't always equal the reality, okay? Don't gamble. But let's try this experiment just because it's kind of fun to test out our theory. All right, let me get the spinner here. Bear with me a second. I'm going to keep a little tally on my whiteboard. You keep a tally on your paper as I roll this dice. At the same time I roll the dice, I'm going to spin the spinner. This is exciting. Hang on tight. One more drink of coffee. All right, here we go. On your mark, get set, go. I don't know why I'm telling you go, because you're not spinning it, but I am. I got a 2 and a right hand. How about that? First one, because we were looking for a right hand and even, right? So far, oh my gosh, we're a 1 for 1. Is that good or bad? It's kind of bad, right? Because in theory, it should only happen once out of 8 tries. So far, we're 1 for 1. So what should happen these next 7 trials? That's right, we should fail, right? We should not get right hand, or we should not get even. All right, here we go. Spinning, rolling. I got a 1, so it doesn't even really matter what the spinner said. I'm 1 for 2 so far. All right, next one. Spinning, rolling. I got a 5 and the left foot, so it doesn't matter. 1 for 3. Here we go. This is exciting. Spinning, rolling. I got a 1 and left foot. 1 for 4. It's looking better. Here we go. Spinning, rolling. I got a 6, but left hand. There you go. 1 for 5. How many? I have 2 left, right? No, I have 3 left. I'm 1 for 5. Okay. I need to do 8. Spinning, rolling. I got a 1 and a right foot. 1 for 6. 2 more. Here we go. Spinning, rolling. I got a 4, but left foot. 1 for 7. Oh my goodness. Could our theoretical equal our experimental? Time will tell. Right now, I'm going to tell you. Spinning, rolling. I got a 2. Right hand. How exciting is that? We are 2 for 8. So we were supposed to be 12.5%, but we ended up at 2 out of 8, which is 1 out of 4, which is 25%. Which goes to show you that the theoretical does not always equal the experimental. We got 25%. We were supposed to get 12.5%. Don't gamble. There you go. We are not quite done, but you smell that? It smells like the end of the lesson. We're almost there. Just like that, we're almost done with 3 standards. All right, let's try a couple more, and then I'm going to teach you the FCP, the Fundamental Counting Principle. I know you've been on the edge of your seat waiting to hear this. All right. Let's try one more with the spinner. Let's do the probability of, let's switch it up. Let's do left foot and rolling a number. Roll a number bigger than 4. Probability of left foot and a number bigger than 4. Could you make a tree diagram? Of course. Would I suggest it? Not really, because it's going to be big, not as big as the last sample space, but it's going to be probably larger than really you want to do, especially on a computer. So let's try the shortcut. All right. So probability of left foot would be what? That's right. It's still 1/4, right? It's still 1/4. But now, what's the probability of getting a number on the dice, rolling a number bigger than 4? Not equal to 4, but bigger than 4. How many possibilities? That's right, there's only 2 out of 6. So this is 2 6, which we can reduce obviously to, where'd my eraser go? We can reduce this to 1/3. This is going to make the multiplication a little bit faster. So the probability of left foot and a number bigger than 4 would be 1 out of 12. All right. I don't have, obviously I've been erasing. I'm questioning my math on one of the previous problems. 1, did we do, and correct me if I'm wrong, did we do right hand and roll 5? Starting to doubt myself. Got a lot of things going on up here, and sometimes I forget what I just did like 5 minutes ago. I can't remember if we did this one, and if we did, I'm not sure if we did it right. So I'm starting to question some of the numbers, which is one disadvantage of just using a whiteboard as opposed to the smart board at school. But right hand, we know is 1/4. Rolling a 5, I think we did this one, would be 1 out of 6, right? This is what I'm questioning. I'm not sure if I multiplied this right. This would be 1 out of 24. That's why I don't know if I multiplied this one right. So sorry if I messed that up. This should be the correct answer. If I had it right the first time, then I'm just forgetting what I did. But I'm not sure if we got 1/24th, but that's what it should be. This is how many times it should happen. So the sample space is 24 big, which is much, much smaller than the 1/8 that we just experimented with, and also smaller than the 1/12 that we just completed. All right, so sorry if I lost you on that, but I just couldn't remember if we did that one. All right, last question, and it's actually the last standard. So this is kind of a what if. What if the sample space is really big, like over 50, or even worse, like over 100 or up in the thousands? A couple times we've been to, it's a sandwich shop, it's called Which Wich. We don't go there often, but when it first opened up down in Greenwood, we went a couple times. They give you this bag, and on the bag they have all the types of breads that they have, and they have like 6 breads. Then they have, so we'll call it 6 breads. Then they give you how many meats you have to choose from, and it was like 10 different meats. And then they had like 8 different cheeses. And then here's the kicker. They had like 20 different vegetables you could put on it. And then even worse, they had like 24 different condiments. And all of these items are listed on this brown bag that they give you when you walk in. I think there's actually, I have this at school. I have the bag. It's stuck in my math book at school that I can't get. Then I think they had like 8 different spices that you could put on your sandwich. And it's really good. I'm not knocking Which Wich. It's a good place to eat. But there are so many different choices in each of these categories. So my question is, how big would this sample space be? In other words, how many different possible sandwiches could I order? It's a really, really big number, right? Because there's so many different choices that are possible when you walk in. We're going to not use these really large numbers. We're going to kind of shrink it down a little bit. But I'm just trying to show you that this is, number one, this is real life. This is real life. You're going to see one on your Google Doc here today. But number two, this could get really big really fast. The more choices that they offer you in each category, the number of different possible sandwiches just explodes into a really large number. So let's look at, and by the way, making a tree diagram on this, that's a bad idea, really bad idea. You could do it, it's going to be much bigger than the piece of paper that you have in front of you, and definitely much bigger than this whiteboard that I have. So we're going to use what they call the FCP, and it stands for the Fundamental Counting Principle. The FCP, the Fundamental Counting Principle. It's a fancy way to say how big is the sample space. How big is the sample space? And let me go ahead and tell you what this principle says. You're going to multiply. I hope you've caught on in this video that multiplication is like the main, the key operation that we're using here. We're going to multiply the number of possible outcomes or possible choices from each category. You're going to multiply. Again, if you need to pause the video, you're going to multiply the number of possible choices from each category. I'll give you a chance to pause the video, and I'm going to go ahead and start erasing. I'm going to put up one more time just in case you didn't get it. Multiply the number of possible choices from each category. Again, multiplication is the key. So instead of using which, let's use like Pizza Hut, okay? So let's suppose you went to Pizza Hut or maybe got online and looked at their menu. And let's suppose they had three different crusts to choose from. It's 3 different crusts. They had like thin crust, New York thickness, New York style crust, and like the traditional crust. So they had 3 different crusts to choose from on their website. And let's suppose they had 5 different meats: sausage, pepperoni, ham, bacon, and Italian sausage. So 5 different meats, and they had 8 different vegetables: onions, broccoli, tomatoes, peppers, mushrooms, so on and so forth. So 3 different crusts, 5 different meats, 8 different vegetables. My question is, how big is the sample space? In other words, how many choices do you have? Sorry, it's a little bit messy. So kind of 2 questions here. How big is the sample space? If you got online for Pizza Hut and you were the one in charge of ordering the pizza, you were the one making all the decisions, how many different ways could you order this one pizza? If you had 3 different crusts, 5 different meats, 8 different vegetables, how big is the sample space? In other words, how many possible choices do you have to order one pizza? It's a lot simpler than you probably think. You could make a tree diagram. Not suggested, again, because it's time consuming, B, it takes a lot of space to do it, and C, there's another way to do it. The key is multiplication. So you're going to take your 3 crusts multiplied by your 5 meats multiplied by your 8 vegetables. And you multiply this out. Again, you have a calculator. I don't, but I think this is, gosh, I hope I got this right. I got 120 possible, I'm just abbreviating here, possible choices. And that's how big your sample space is. That's how many possible outcomes are contained within your sample space. So literally, when you're sitting there at the computer trying to figure out what pizza to order, you have 120 different possibilities to choose from. You could get thin crust with, and assuming you only choose one meat and one vegetable, you do thin crust, pepperoni, onions. Or you could do thin crust, pepperoni, mushrooms. Or thin crust, pepperoni, peppers. So there's lots of different choices. In fact, there's 120 of them. All right. The examples, the problems that you see on Google Classroom are going to be very, very similar to what we just did here in this lesson. As always, if you have any questions, please email me. I'd be happy to help the best way I can from a distance. And those are the last three main standards that we needed to hit as 8th graders. So, moving forward, starting with the next video that we have with your next assignment, not today's assignment, but the next assignment, as I've already mentioned, we're going to really hit pretty hard those main standards, especially the algebra standards from 8th grade, so that when you walk into the first day of school as a freshman in the algebra class, you're going to be rock solid on those algebra standards. That's my goal every year, whether I'm sitting at school teaching or I'm sitting in my basement teaching. My goal every year for the 8th graders is to really kind of drive home those main algebra standards, so that when you walk into the first day of algebra class, you are feeling comfortable and confident with your algebra skills. So slope-intercept form, perpendicular and parallel lines, solving equations, graphing equations, so on and so forth. The list goes on and on. Systems of equations, functions. These are all things we've talked about this year, but we haven't seen for about a month or two because we've been focused on probability and also geometry. But all of you are taking algebra next year, and I want to make sure that you are rock solid on the algebra standard. So that's our goal moving forward. It's every year. Every year we really hit those algebra standards hard at the end of the year, so that you guys are ready to hit the ground running as a freshman algebra student. So, as always, it's been a pleasure. I'd much rather be teaching in school than staring at this camera, but it's been a pleasure teaching you some probability. I hope you're awake. I hope you didn't fall asleep, and I really appreciate all the efforts that you put into these assignments. Email me with questions. I hope you have a wonderful day. As always, I've been saying in these videos, as always, be kind to one another. Be kind to your family. Be patient with one another. That's one virtue that I think we all need a lot of. And above all, please make sure you're praying. Prayer is really going to pull us through these difficult times, and it's an ultimate form of peace. And I think that's what all of us need right now, is a lot of peace. So be kind, be patient, and make sure you pray. And have a great day. We'll see you guys soon.